property of that node. And elements are the element connectivity list. So if you use 3D, you will have tetrahedron, so which has 4, which is a triangle and one extended, so it has 4 points. And if you use two-dimensional mesh, which is triangle, so you will have only 3. And dimension is 3, and region is, if you want to have 2 different regions inside the node, you have to tag like it will have the same size as the nodes, but you have to tag this node belongs to region 1, this node belongs to region 2, this node belongs to region this, something like that. And source and measurements and the link. I will tell you this too. Link is like channels. So what are the channels you want? If you want to turn on, so first source, first channel, it is turned on. So it determines that. So and then you have C. You don't need to worry about C, psi, and element area and support. So these are all too advanced for you right now. So basically you understand. And within the source you have fixed coordinates. Okay, I'll tell. Coordinates are the XYZ locations of the sources, and the full width half maximum, don't worry about it right now. And these are all the nodes numbering, and this is it. Okay, so
in order to run your code, you have to go to that file to fix according to your conditions.
Yeah, I'll tell like so we view mesh, and I'm just viewing the mesh, and I plot sources and detectors and see how my mesh looks like. So this is my transrectal mesh geometry, and source 1, source 2, source 1, source 2, and so forth. So it is telling that source 1 is here, source 2 here, and so forth. Source plus is like that. 1, 2, 3, 4, 5, 6, 7, and 9.
So why do you have source 1, 2 have different color?
It is the starting order. So it is starting from. It's not starting from here. They are saying it is starting from here. This is 1, this is 2, and so forth.
And those blue small dots are your
detectors.
Nodes. No.
Oh yeah. These sky blue dots are my boundary nodes.
Boundary nodes.
Yeah. So they won't plot inside. So.
Oh.
Yeah, you can turn it and you're just showing a purely boundary.
Only on the boundary side. I see.
Yeah. And automatically this thing pops up. And this one you can see, which is interactive. It is more graphical. So you can see your region if you have 2 different regions, or you can see your mu A. And these are XY, XZ, YZ slices. So you can go like up and down. This is a uniform mesh, so you don't see any changes. So you can just see mu A, mu S prime, and
Why 4? You have XY, XZ, or YZ.
YZ, and this one is a whole, but this one is a whole volume, but you can it's lighter in color. You can see better here. So basically, if something is hidden, we can see it. Okay. Okay, we got the background uniform mesh, and then I want to simulate something. So what I do is I will go ahead and create an anomaly inside that. So standard anomaly and
now hold on. First, can you go back to that 3, 4 plots that are all red? So this is showing the geometry of the source detector, and then this is the uniform distribution of. This is nothing. I mean, it's all zeros. What do we see here?
Right now, so far it's a uniform phantom already.
This is the region. So I didn't tag anything. So all my nodes belongs to region 0. That's why everything is 0 here. So if you go to mu A, then it will show 0.01 centimeter nodes. That's my mu A value. And if you go to mu S prime, it will show 1. So that's my mu S prime value. 1.
So this is already reconstructed?
No. It is background mesh. So
okay. So this is kind of your input.
Yeah.
You put a mesh. Yeah. Nothing inside, just mesh.
The mesh has numbers now.
Yeah.
You have mu X,
Yeah. Mesh with the values. It's not just pure mesh.
Okay. Are you kind of follow? I mean, what happens is that, again, there are a lot of background in terms of the theoretical part of what is mu A, what's mu S, what we're doing there. I mean, we know what are mu A, mu S. I mean, we know the meaning of that, but what do we mean for reconstruction? But at least, I guess, once he's done, you can ask me, or I can give you a little bit of lower level explanation. But on the other hand, what you can do is once you download the software, you can just start trying something. And then you say, okay, what does this mean? Or what do I do here? What if you plot something? So by doing it, you can gradually understand that.
So I'm plotting this again, and you can see this one. Click this one and go to XZ. So I will create an anomaly at minus 20 centimeters from the surface here. So sorry, minus 20 millimeters from the surface. So that is 2 centimeters from the surface. So I'm creating over there. So just let's see. Add anomaly. I'm placing standard anomaly over there. So it will ask what mesh I want to put. I want to put this mesh, and I want to create this mesh as after placing anomaly. Then I will say mesh underscore anomaly, and I'll keep 0, 0, and minus 20.
That's the location.
And radius will be 5 millimeters. So that is 1 centimeter diameter. So, and absorption coefficient will be, let me put 0.02. Is 1 to 2 contrast. And I'm not changing scattering. Refractive index I'm getting 1.33, and the region number I don't want to tag it as separate region, so I'll put as 0. So I don't. No, let me tag it as 1. I'll tell you later. So let me tag this one as 1.
Is that fine to you putting the x and y on 0? Or 0 is in the middle?
Yeah, yeah.
Good.
Okay.
So he's adding a spherical object into this medium.
Yeah. So then I will view whatever I created right now. I'm not taking that because we already know. So here, I created.
It's already reconstructed
No,
now?
no, no.
Now how come you don't get a circular? Oh, it's because of the final element.
Yeah.
Because your
The element is not regular.
your meshes are not circular.
If you want to create round like that, we can also create it, but you need to have a little bit more advanced programming. Yeah. So, but this one is okay.
Yeah, yeah.
Okay.
Are you following what he's doing?
So this one is mu A. So you can see background has 0.01 and this one has 0.02, and this is all set values. So this is all set by us. And what we need to do, so we want to simulate this one. So we assume this one, we want to create some synthetic data from it. So synthetic data means we create the data by ourselves, and we assume that that is coming from from the experiment. So
Put simulated data.
yeah. So mesh practice, it will ask you to anomaly mesh. I'm putting anomaly mesh, and I'm using 0 as frequency, so which means CW. And I will show whatever it is, what are here. So I'm clicking view solution, view data, and 1 through 1. So I'll tell you what it plots.
Only one source? You don't put all of that?
No, it will take lots of time. I'll just the same thing basically.
You're not showing a whole A matrix. It's just showing one source in there.
It's a forward solution, so it's not A matrix completely. So okay, so after I click those 3 ticks, it gives me 3. So this one is solution for the diffusion equation with the finite element method. So here is the source, and it is showing how the fluence, I mean it's a fluence basically, whatever you plot in your Monte Carlo, which is the same in 3D. So
But this has your object inside.
yeah, this has my object inside, but
See that the simulation you are running for Monte Carlo, we're just doing homogeneous. We can inside and we put anything in there. So this gives us much more ability, but I thought this is much harder. But then he says no, but I think you can do it as time goes on. But Monte Carlo helps you to understand. This is a different thing. I'll talk about that later.
I changed the color so you can see.
Yeah, but where's your source? Where did you put the source?
No, if it created for every source, but I just plotted for one source because it will take
Yeah,
up
but where do you put the source?
here.
No, this is on the top.
Yeah, this is 3D. Okay, so here. Okay.
Oh, so you are putting one source there and that shows the distribution. It doesn't matter what's going on inside. Right now you are just looking at the outside
Yeah.
about the distribution.
So I'm just plotting the distribution to compare this one with Monte Carlo. Okay, so here it is that, and the next one, next plot, it is the amplitude log of y, and x is the measurement. So basically it will say first source, first detector, first source, second detector, first source, third detector, fourth, and fifth, sixth, seventh, eighth. By fifth you will get the second row. So my mesh is like this, right? So this is first source, some source is somewhere here. So first source, first detector, second, third, fourth, and again fifth. It went up a little bit, 6, 7, 8. So that's why it has that pattern. So when you are just starting right now, you don't understand this one. But when you are advanced user, you just see this one and just say your data is good or not. I just see this and say the data is good or not.
No.
So this data is medium. It's not pretty good because of number of nodes I used. So.
But why do you have 8 repeated? So you are taking all eight sources there?
Yeah. So this one is for the first source, second, third, fourth, fifth, sixth, seventh, and eighth.
Yeah.
If you use cylindrical mesh, you'll get pretty nice pattern like that.
Cylindrical.
Or circular mesh. Circular or cylindrical mesh.
Now, by the way, don't feel bad if you say, oh, this is too much. For official course to be taught during conferences, they charge $400 for like 2 days.
For this one?
Yeah.
Oh.
For an hour fast.
Okay.
So then right now, he said, easy, 1 hour, said let's do it. But then we just need to know how to run just now, but then you can try a little bit, and then we can come back to talk about it and so forth.
Okay, this is this, and then phase. So as you know, CW doesn't have any phase, so phase is 0. So no change in phase. So if you see sometimes some phase, that means your mesh is bad, basically. So if you have pretty less number of nodes or something like that, you see some values in the phase, that means your mesh is bad. So you go back and redo your mesh and check everything is good, and especially on the boundary. Boundary has to have lots of number of nodes so that the source will sit on the top of it. So okay, 1 second, sorry. I forgot to tell one thing. Okay, so if you can see, the source is little bit inside. It's exactly one transport scattering distance inside from the surface. That's because from their simulations they studied that if you put one transport scattering distance inside, then the data from this geometry will be more realistic to the experimental data. That's why it automatically puts this thing into one transport scattering inside. If you don't want it, then just when you create your mesh, you just has one tag called fixed. So you just remove that tag and you just put that tag fixed, then it will stay right over there only. Otherwise it will calculate the distances of everything and it will just put source on transport scattering distance. And detector will be always on the surface.
See, I know all those theory, but I have no idea how to run this software. And then this is the time for PhD students. By the time, as I said, when you graduate, you're better than your advisor. That's part of that. But also, you can start learning how to use it. But then sometime during the process, then I'll give you more theory part.
So if you have just data and if you just want to view data, then just go to view data and just show it's the data, and it will plot the same thing as what it plots previously. And it has one additional feature over here. It's called analyze data, and go to this analyze data, and it will ask what kind of data you have. I have this data. And what kind of mesh you have. I have this mesh, and it will plot this linearly decreasing this one, and it also plots a fitted line here. And you can say, if you can use your judgment to remove some data if you want to, or if you don't want to remove some data, it's up to you. So basically you can set some tolerance here. So if you increase the tolerance, it will tolerate all the data. If you